Today, in this video, we will go through the process of building a handmade stove using familiar and easy-to-find materials, mainly recycled items. The entire process is recorded step by step, from preparation and fabrication to assembly, actual operation, and finally cooking a simple dish to test its effectiveness. This video is intended as an experiential sharing of the process rather than a professional tutorial, so safety must always be kept in mind throughout the entire process. First, the main material chosen is a used metal milk can. The can has been thoroughly cleaned, all residue inside removed, and left to dry naturally. When holding the milk can in hand, it is easy to see that the original opening is quite small and not suitable for installing the upper components. Therefore, the first step is to mark the cutting position. Using a marker pen, a circular line is drawn evenly around the mouth of the milk can. During this process, one hand holds the pen steady while the other slowly rotates the can so that the line is continuous and not broken or uneven. This is a very important step because this line determines the shape of the cut that follows. Once the marking line is complete, the cutting process begins. A handheld cutting machine is used to carefully guide the blade along the marked line around the mouth of the milk can. While cutting, it is important to maintain a firm grip and avoid pushing the tool too quickly to prevent the blade from slipping off the line. The cut is made slowly and steadily until the opening is fully cut out. After cutting, the metal edge is still very sharp and uneven. To address this, sandpaper is used. The sandpaper is rubbed evenly around the mouth of the milk can while continuously rotating the can so that all edges are smoothed uniformly. This step should not be rushed, as any remaining sharp edges could easily cause injury during later assembly or use. When the edge feels smooth to the touch and no sharp burrs remain, this step is considered complete. Next, a used oil filter is taken. This oil filter will serve as the upper combustion chamber. The oil filter is placed onto the mouth of the milk can to test the fit. At this stage, it is not fixed in place, but only positioned to check alignment. The filter is observed to see whether it tilts or catches at any point. If there are areas that do not fit properly, the mouth of the milk can is lightly adjusted and sanded until the oil filter sits neatly and aligns straight with the can dot. Once the fit is confirmed, a pen is used to mark the positions for the stove legs. These marks are made around the body of the can near the bottom, ensuring that after the legs are formed, there will be sufficient space underneath for air circulation. This airflow gap is crucial because it directly affects the stove's combustion performance. After marking the legs, attention is turned to positioning the ventilation fan. The fan is placed at the lower section of the stove. Its purpose is to create an upward airflow, helping the combustion process remain stable. The fan is positioned and checked to ensure it does not touch the walls of the can and has enough space to draw in air. Next comes the creation of the valve opening. An old motorcycle valve is used. A hole is drilled or cut to the appropriate size for installing the valve. This hole must be made carefully too large and the valve will be loose. Too small and installation becomes difficult. Once the hole is completed, the motorcycle valve is installed into the oil filter. The valve is checked to ensure it is secure and functional for airflow or fuel regulation when needed. After all, individual components are prepared. The oil filter is placed on top of the milk can once again. The alignment is checked to ensure both parts share the same axis. Then AB epoxy glue is used to secure them together. The two components of the epoxy are mixed thoroughly in the correct ratio until the mixture is uniform. The glue is applied around the contact edge between the oil filter and the milk can, and the parts are held in place for a period of time while the glue begins to cure, while waiting for the epoxy to harden. The fan is tested using a battery. Power is connected to the fan to ensure it runs smoothly. The fan is observed to see whether it spins evenly, vibrates excessively, or produces unusual noise. Once the fan is confirmed to be operating properly, the process can continue. After the epoxy has fully cured, a second container is cut to form an outer shell. This outer container serves to enclose the structure, increasing safety and creating an insulating air gap. The container is cut so that it can fit over the assembled stove structure. Once placed, its fit is checked and adjusted if necessary. Next, a plastic tube is connected to guide fuel into the oil filter. A suitable plastic tube is selected, with one end attached to the prepared opening on the oil filter. The other end is reserved for connection to the fuel container. During installation, care is taken to ensure the tube is not bent, kinked, or leaking. Allowing fuel to flow smoothly, sand is then poured into the space between the oil filter and the milk can. The sand is added gradually while gently shaking the assembly so that the sand spreads evenly. This sand layer helps with insulation and stabilizes the stove structure when operating at high temperatures. The fuel container is made from a plastic water bottle. The bottle is washed thoroughly and the cap is checked carefully. A small hole is made in the cap to attach the plastic tube. After installation, a small amount of water is poured in to test for leaks. Once confirmed to be sealed, the bottle is used as the fuel container. When everything is ready, alcohol and waste oil are poured into the fuel container in moderate amounts. The cap is tightened securely, and the container is connected to the system. The stove is placed on a stand in a well-ventilated area. A fire starter is used to ignite the stove, while power is supplied to the fan to create upward airflow. The flame begins to form and gradually stabilizes. Observation shows that the stove burns evenly and the flame is well focused. At this point, a frying pan is placed on the stove and cooking oil is added. Once the pan heats up, an egg is cracked into it. As the egg cooks, it confirms that the stove is functioning effectively. When the egg is fully cooked, the stove is turned off. This concludes the fabrication and operation process. The egg being cooked means success at this point. It can be seen that the stove body made from the milk can remain stable and has not deformed excessively under heat. The sand layer between the oil filter and the milk can clearly performs its function, reducing direct heat transfer to the outside and reinforcing overall structural stability. When placing a hand near the outer wall, the surface is still hot, but not excessively so, indicating that the temporary insulation is reasonably effective under test conditions. The ventilation fan located at the bottom is observed further. While operating, it produces a steady airflow upward. This airflow helps maintain a consistent flame without flickering or interruption. During the egg cooking process, the flame remains concentrated and does not spread outward excessively, demonstrating that positioning the fan at the lower section is a reasonable design choice for this. Temporary setup. The motorcycle valve installed in the oil filter also demonstrates its usefulness. Although it was not adjusted much during this test, the valve remains airtight, shows no leakage and feels solid to the touch. In future uses, fine-tuning airflow or fuel delivery through this valve could play an important role in better combustion control. The plastic tube delivering fuel from the container to the oil filter is checked again after the stove is turned off. The tube shows no significant deformation and no signs of melting or softening, indicating that its placement and distance from the heat source are acceptable for this short test. However, the video should emphasize that this is only a brief experiment, and for long-term or frequent use, replacing it with more heat-resistant materials would be advisable. The fuel container made from a water bottle retains its original shape and does not leak during operation. The cap remains tightly sealed, and the connection with the tube shows no signs of seepage or dripping. This confirms that careful preparation and inspection before operation are essential to avoiding unwanted risks. When filming close-up shots of the stove after it has been turned off, soot and burn marks can be seen inside the oil filter. This is completely normal for a combustion process. These marks also serve as visual evidence that the stove has truly been used and is not merely assembled for appearance. Capturing these details in the video gives viewers a more realistic understanding of the final result. Next, the narration can include personal reflections on the entire process, from marking the milk can with a pen, cutting with a power tool, sanding the edges, fitting the oil filter, marking the stove legs, positioning the fan, installing the valve, securing components with epoxy, cutting the second container, connecting the plastic tube, adding sand, making the fuel container, and finally lighting the stove and cooking the egg. All steps form a tightly connected sequence. Skipping or carelessly performing any single step could have led to a very different outcome. The video can also emphasize that this is not a finished or optimized product, but rather a process of experimentation, learning, and hands-on experience. The main purpose is to reuse available materials, gain a better understanding of combustion principles, airflow, component layout, and most importantly, to practice patience and careful work in manual fabrication. Everything shown in the video requires caution. The process should not be rushed, should not be attempted in enclosed spaces, and safety measures should always be prepared in advance. This homemade stove is intended only for experimentation and experience, not as a replacement for professional cooking equipment, and so, the entire process from preparing the milk can to cooking the egg completely in the pan has been fully documented. The video ends here, leaving behind the image of a small, simple stove that embodies many steps, effort, and valuable hands and experience behind it. Asterisk, asterisk.